Hey everyone, let's do this lesson 2 practice. Is that what this is called? What did we name this? Equations and expressions lesson 2 practice. That's what we're working on today. And so here's your first screen. It says match each equation. Let's get rid of these teacher answers down here. Match each equation with either diagram A or diagram B. You may have some cards left over. So we got diagram A here. Looks like an equation that would be 4 plus 3 equals 7, total length of 7. And one here where you've got a total length of 12, and it's broken up into 3 sections of 4, so maybe like 3 plus 3 plus 3 plus 3, or 3 times 4, or maybe 4 times 3. Let's see. All right, so this one looks pretty clear to match with B, right? 3 plus 3 plus 3 plus 3 equals 12. I don't know if I said that too many times. And then this one here as well, right? 12 equals 4 groups of 3. So I like that one. Over here, I see we have 7 equals 3 plus 4. So I think that matches this diagram. And I don't think we have any other matches. These two equations here, these are what we would call false equations or untrue equations. 4 times 3 equals 7. It's not right, right? We say it's not true though. The same thing with 4 minus 3. That's an untrue equation. 4 minus 3 does not equal 7. All right, let's move on. Vihan collects stickers. He has X stickers. So that's just a way of saying we don't know how many stickers he has. After getting 15 more stickers, he has 60 stickers total. How many stickers did Vihan start with? All right, well, let's see here. I could write this like this. We could go some question mark, some value we don't know, plus 15, right? Because Vihan, he gets 15 more, that equals 60. This is the way I would write it probably if we were in 6th grade. But since we're in 7th grade now, we use this X to represent this unknown number of stickers. So same thing, but this time it's X plus 15 equals 60. And now I'm going to use the inverse operation. Inverse operation. So what I mean by that is, for addition, the inverse operation is subtraction, because subtraction does sort of the opposite of addition. You can undo addition with subtraction, and vice versa. You can undo subtraction with addition. Multiplication and division are the same way. They are inverse operations of each other. So you can undo multiplication with division, and you can undo division with multiplication. And the fact that those operations undo each other is really useful in solving equations like this. Because if I have some number that I don't know, right, this unknown number here, but I know that when I add 15 to it, I get 60. Well, that means if I subtract 15 from 60, I should be able to get back to this unknown number. So I want to subtract 15 over here. Well, the thing about equations is, in order to maintain their trueness, in order to keep the scales of the two sides of the equal sign like balanced, if I take 15 away from this side, I have to take 15 away from this side as well to keep it fair and equal. So I'm going to write minus 15 here as well. One on this side of the equal sign, and another minus 15 on the other side of the equal sign. And so what happens is, on this side, I get 60 minus 15, which equals 45. And then on this side, I have my x, and I have plus 15. Well, these two things right here, they match up really nicely, right? Plus 15 and minus 15, those are additive inverses of each other. They make 0. So we come to a new equation now, a new true equation, because we subtracted 15 from both sides. It stayed true for us. But the new equation is x plus 15 minus 15 equals 45. But plus 15 minus 15 equals 0. So it's x plus 0 equals 45, which I think tells us that x equals 45. There was a lot of extra work in here. This step here and this step here, most people would not write these steps. They would skip this. I wrote them out to help you kind of see what was happening and help you understand what was happening. But usually people would go from the step where I circled the 15s down to the solution. So I think the answer is 45. Vihan started with 45 stickers. Okay, so this is the same prompt. It's still about Vihan having X stickers, and after he got 15 more, he had a total of 60. And they want us to select all of the equations from these options that would give us a true value for X. So X equals the number, this little symbol right here, you might think of as hashtag most of the time. It can also be used as an abbreviation for number. Number of stickers Vihan started with. So what I'm doing right now is I'm defining the variable. It's a really good practice, and in fact, you should always do it. Anytime you're working with a variable, define it, which means like somewhere on your page or on your screen, write what that variable actually represents or stands for. All right, and so we know, because we did the math on the previous screen, we know that X is supposed to equal 45. And so we just need to pick all these equations where X is gonna work out to equal 45. This first one says X equals 60 minus 15. That works, right? And that might be the most intuitive way to solve this question. And say, oh yeah, 60 total now, but 15 of them are new. All right, I'll just do 60 minus 15. That would tell me how many he started with. That's essentially what this equation says. Okay, X equals 60 times 15? No, come on. 60 times 15, that's like 900. He didn't start with 900 stickers. X plus 15 equals 60. Now this one's close, this third one. But what this says is if you take the number of stickers he started with, add 15, that should equal 60. Oh wait, what am I talking about? That one's right. It's not close. That's the exact one I used on the previous screen. I'm like spacing out or something. All right, this next one. 15 times X, or remember when you put a number right next to a variable like that, 15x, that means 15 times whatever number X equals. So in this case, it'd be 15 times 45. We don't want to do that. So let's skip that one. The last one is what I thought the middle one was when I was saying it was close. This one says X equals 60 plus 15. So this would be like if Vihan started with 60 stickers and got 15 more, then that would be a correct equation, but that's not how it worked. So I don't think we should select that one. Okay, select all of the equations that are true when X is -4. So what you're being asked to do on this slide is called verifying solutions. Or verifying a solution, I guess I should say. And so this right here, saying that X equals -4 is a proposed solution. Like Desmos is essentially proposing to us, not like marriage, proposing to us the idea that the X in each one of these equations equals -4. And it's our job to go and verify that solution. A number is a solution to an equation if you can substitute it for the variable in an equation, right? I'm going to take this -4 and I'm going to substitute it for this X in this equation. If the equation then becomes true, it is a solution. If the equation is untrue with that number in it, then it is not a solution. Okay, so let's try it. This first equation becomes -12 equals -4, right? I'm just writing the -4 instead of the X now. times -3. It looks like this would almost be true, but it's not quite, because -12 equals -4 times -3. This is a time symbol here. That's +12. So I've arrived at a very untrue statement. -12 equals +12? Nope. So -4 is not a solution to this equation, or in other words, -4 does not make this equation true. So it's not selected. Let's try the next one. I'm going to substitute -4 for x into this equation. So I put -4 on top of this fraction, divided by 4 equals -1. I think this one's going to come out true, right? 4 divided by 4 is 1, but I've got that negative up there. So the equation becomes -1 equals -1. That's a very true equation. So that means that -4 is a solution to this equation, and we should select it. And let me pick another color because I got a lot of writing on the screen now. So the next one we'll do in red. The equation is -12 equals x plus x plus x. So instead I'm going to write -4 plus -4 plus -4. And remember, if you're adding a bunch of numbers and they're all negative, you can add them as if they were positive and then just throw a negative sign on your answer. So this equation says -12 equals 4 plus 4 plus 4 is 12. But since they were all negative, I put my negative sign. Yeah, we got another true equation, right? -12 equals -12. So that means -4 is a solution to this equation. It makes it true, and we select it. All right, let me pick a different color. Let's go with green for this one. So I'm going to take the -4, and I'm going to substitute it for x in this equation. And so I'll rewrite it. -4 plus 4 equals -8. This is not true, right? I got a -4 to +4. When I combine those, I get 0. 0 does not equal -8. So -4 is not a solution to the equation that I drew the green arrow to. Okay, and then the last one, let's use purple. I'm going to take -4 and I'm going to substitute it for the x right here in this equation. Let's see here, I'll work right here. So the equation becomes -8 equals 2 times -4. Remember, when you have 2 right next to the x in an equation like that, that means 2 times whatever x equals. So when I put -4 in there, it becomes 2 times -4. Well, 2 times -4 is -8. And so I get a really true equation. -8 equals -8. So that means -4 is a solution to this equation because it makes it true, and I should select it. All right, let's move on to the next one. Determine the value of the variable that makes each equation true. So a value for a variable that makes an equation true is exactly what you mean when you say a solution to the equation. And finding the solutions to an equation is exactly what you mean when you say solve an equation. So this is just another way of saying solve these equations. All right, well, the first one says 8.5. I'm going to do this one in purple. 8.5 times -3 equals A. 8.5 times -3. Remember, I can put a number right up against parentheses with no dot between, and that still means times. Okay, well, 8 times 3 is 24. 3 times 0.5 is 1.5. So this is 25.5. But it's negative because I got negative times positive here. And so -25.5 equals A. I think we can just write the value. We don't have to write equals A or anything like that. And let me get a different color. We'll go with red. Next, we have -7 plus B equals -11. I want you to think of this one like this way. Let's do it tape diagram style, the way that the lesson does it, right? So let's say you had a tape diagram here, or well, this is more like the total. And it says the total length of this tape diagram is -11. And then you've got a section underneath that says, okay, this part is -7, and this part is B. And so if you're in my class, the way I was showing you to think about it was, if you take away the numerical part, the part that we know, so with the -7 here, then we just want to know what this length of the tape diagram is. And we can get that by taking -7 away from the total length. So we do -11 minus -7, right? I have to subtract the negative because the length itself was negative. Well, subtracting a negative is the same as adding a positive. So what I get is -11 plus 7, which is -4. So that means this length right here is -4, right? And that just covers just the B. So B must equal -4. Let's look at the algebraic way to do that one though. It would have been -7 plus B equals -11. Well, I want this -7 to like go away, and I want to have the B all by itself. That's called isolating the variable. Well, I can isolate this variable. To isolate something means to get it by itself. If I just get rid of this -7, I use an inverse operation. If I have -7, -7, kind of the same thing, I can add 7 to that, and those two things will cancel out and make a 0, right? -7 and +7. But with equations, if I do something to one side of the equal sign, I got to do the same thing to the other side of the equal sign. So I write +7 over here. These two cancel out. They go away and make a 0. I'm not even going to bother writing that 0. I'm just going to let it go away. And so I still have my B. My equal sign comes straight down. And then -11 plus 7 equals -4. So it's just another way of getting that same answer. Okay, next we have C minus -3 equals 15. So I'll work this one. Oops, no, here. I'll work this one right here. So first thing I'm going to do is I'm not going to even write minus -3. At this point, you should know that minus a negative is the same as plus positive. So I'm going to write C plus 3 equals 15. And now I'm going to use an opposite operation or inverse operation. I want to get C all by itself. I want to isolate that variable, as they say. Because then I always wind up, when I isolate the variable, I always wind up with an equation that looks like this, right? Just letter equals number, and it tells me what the answer is. That's what I want every time. And so I see a +3, I'm going to use a -3, right? Because I know that +3 and that -3 are going to make a 0 and go away. But if I do it to one side of the equal sign, I have to do it to the other side of the equal sign. And so what I'm left with is just my C on this side of the equation, because the +3 and the -3 make a 0. I'm going to bring down my equal sign. 15 minus 3 is 12. So the answer here is 12. The solution, I should say. When we're working with equations, it's proper to say solution, not answer. Okay, so how about we test it? How about we verify our solution? What if we were to take this 12, put it where the C is in this equation? Does it make the equation true? 12 minus -3 equals 15? It does, right? Because minus negative is the same as plus positive. So what we're really doing is 12 plus 3 equals 15. That's a true equation. It's always a good idea to go back and check your answers in that way, verify them. Put your answer or your solution in your equation and see if the equation works. If it doesn't, you probably messed up somewhere. All right, and the last one. Let's hear. Let's use some green. D times -4 equals 32. So really the way this is supposed to be written is like this. -4D equals 32. I think Desmos is writing it this way to help you see exactly what's going on, but the proper way to write this is -4 times d. Well, -4 times d is a multiplication, right? And the trick to solving these is using inverse operations. I see multiplication happening right here. This is multiplication. I'm going to undo that multiplication to get the variable by itself, to isolate it, by using division. I divide by -4, because I know that that's going to give me a 1. -4 divided by -4 equals 1. Any number divided by itself equals -1. But if I do it to one side of the equal sign, I have to do it to the other side. And so what happens here is -4d divided by -4 equals 1d. Most of the time, we don't even write this 1, but I'm just writing it there for you to see. And then 32 divided by -4 equals -8. Well, 1d is the same as d, right? Those two things are equal. You just usually don't write the 1. So what we have here is d equals -8. And do you see how that solution makes sense? If you put a -8 where d goes, then the equation becomes -8 times -4 equals +32. That's true, right? All right, let's move on. Did I accidentally skip one? All right. Axel wants to save $40 to buy a gift for his friend. His neighbor pays him weekly to mow the lawn, and he donates $2 of what he earns each week to charity. Axel calculates that it will take him 5 weeks to earn enough for his friend's gift. Which tape diagram represents the solution or this situation? So I think the main thing that's happening here is this: $2 of what he earns each week. Because his neighbor pays him each week, right? Pays him weekly. And so I think each one of these segments in the tape diagram is meant to represent 1 week. So this one would also represent 1 week, etc. And each of these is, well, it says here that Axel calculates that it will take him 5 weeks to earn enough for his gift. So first thing I see is that this one right here has 5 sections, and this one has 6. But the other thing I think is important is to notice that if he's taking $2 out of what he earns every week, then $2 should be taken out of his earnings each week. And that's what's happening here. You see the -2, the -2, the -2. Whereas in this one, there's only one -2 in the whole thing. And to me, that would be like if the problem said, at the end of the 5 weeks, he donates $2 one singular time, right? Not every week. Every week is happening in B. So as far as the equations that come from this, in tape diagram number A, I see 1, 2, 3, 4, 5 x's. And you can write that as literally 5x, right? 5 times x. Then -2 equals 40. This equation matches this tape diagram, but this tape diagram does not match the question. For B, I see x -2 plus x -2 plus x -2 plus x -2 plus x -2. So I'm going to put, oops. I'm going to put x -2s in parentheses. If we were going to write this equation, we could combine the like terms. So the like terms are the x's, because they're terms that all have the same variable, x. And you can combine them simply by putting them together and counting how many you have, really. I see 1, 2, 3, 4 x's, so that's 4x. Notice when I write 4x, that doesn't mean that x is 4. That means that I have 4 of whatever x is. And then I have minus 2, but I want you to think of that as negative 2. And then another negative 2, another negative 2, and another negative 2. Well, that's negative 8, which I could write as 4x minus 8 equals 40. Or I could write as 4x plus negative 8 equals 40. Both of those are okay, and it's sort of a stylistic choice of which one of those you prefer. But anyways, the question was really only asking which one of these tape diagrams is right, and B is right. As far as how do those explain, how does this match the parts of the story? I think I've already said that. So if you were listening and paying attention to the video, you should be able to fill out this explanation box without me having to really repeat it. All right, so number 7. Well, I guess problem 5.2. It's the same question, same prompt, same information. Notice they've like kind of faded out the A tape diagram because it's the wrong one. They want us to use the B tape diagram, and they want us to figure out how much is X. Okay, well, let's do it a couple different ways. Notice how each one of these boxes has a minus 2 in it, and that's from each time Axel takes $2 out of his pay and like donates it to charity. Well, what if we got rid of that minus 2? What if we just wanted to know about X? Well, then what I've essentially done is like given Axel 2 of his dollars back, right? Like we're almost pretending that he didn't donate it to charity. And what that's going to do is it's going to increase his total money by 2. So I should almost make this length a little bit longer, right? But what if I did it here again as well? He never gave that $2 either. Well, then that means it's got to be a little bit longer now too. It's got to be a little bit longer by 2. And this is an extra 2, right? Because this top number here represents how much money he has total. And this is going to go up every time I'm like being evil and canceling out his charity donations. So now he's got another $2. Now he's got another $2. And now he's got another $2. And so now let's see what the new total of all the money he would have got if he never donated to charity at all would have been. 40, 42, 44, 46, 48, 50. So he would have got a total of $50. Now, those $50 have to be spread between these 10 boxes that each have some X amount in them, right? So what if I made 50 little dots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those 50 dots represent the total $50 that he got without like donating to charity. And it looks like he worked for 5 weeks because there's 5 boxes with X's in them, and X represents the amount of money he works each week or makes each week. In fact, I should define that variable, right? X is the money he makes each week. Well, if I can just split these 50 little dollar dots that I drew into the 5 boxes evenly, then that tells us how much X is worth. Well, that's actually pretty easy. It's easy to split 50 into 5 equal parts, right? Those 10 can go in that box. And these 10 can go in that box. And these 10 can go in that box. And these 10 can go in that box. And lastly, these 10 can go in this box. And so what that tells us is that each of these little boxes that just has an X in it, because I canceled out the -2's, well, 10 per box, X equals 10. Now let's look how to do it algebraically. Remember on the previous screen, I showed you that this whole equation, x minus 2 plus x minus 2 plus x minus 2 plus x minus 2 plus x minus 2 could be written as 5x plus -10 equals 50. Now I'm realizing this isn't the exact same thing I wrote on the last screen. I think on the last screen, I might have misread it and only seen 4 boxes instead of 5. Because what I wrote on the last screen was 4x plus -8. Now I'm realizing it's 5x plus -10. Oh, look at this other mistake I made. Wow, I'm messing up. I wrote equals 50. 50 was the number I got when I canceled out all his charity donations, but I haven't done that yet. I need to write this in a way that matches the tape diagram here. And so this is 5x plus -10 equals 40, right? All I did was I'm taking the 5 x's from the boxes, 1, 2, 3, 4, 5. That's where I get 5x. And then each one of these had a -2 in them. Let me erase this. Well, if I think of each one of those -2's as -2, then I'm doing -2 plus -2 plus -2 plus -2 plus -2 gets me -10. And then I just grab the 40 from the top. Now I'm going to use inverse operations. I see a plus -10. I want to make a 0 out of that. So I'm going to make it clash with a positive 10, right? -10 and positive 10, you put them together, they make a 0. So plus positive 10. But if I do it to one side of the equation, I must do it to the other side. And so these two are going to make a 0 for me, just like I wanted. That was the whole point why I'm doing this step. And so I still have my 5x. I bring down my equal sign. 40 plus 10 equals 50. Now I'm going to use another inverse operation. I look at what's happening in the equation, and I see that this is a multiplication. 5 next to x means 5 times x. I undo multiplication with division. So I'll divide by 5 here, and I'll divide by 5 here. Notice how this was essentially the exact same thing I did with the tape diagram. I subtracted all these, well, more like I added 2 to each one of these boxes to get rid of the -2's. And what that caused was for the length of the diagram to go from 40 to 50. That's what I did in the first step. I added 10 to one side of the equation, and that caused the other side of the equation to become 50. Then I drew these 50 dots, and I divided them into 5 equal boxes to see what x equals. That's exactly what I'm doing here. I have 50 on this side of the equation, and I'm going to divide it into 5 equal parts to see that x equals 10. So it looks like the neighbor pays him $10 to mow the lawn. Select all the stories that this tape diagram could represent. All right, it looks like x plus x plus x plus x plus 39 equals 87. So the first one says there are 87 first graders in the school. After 39 students are picked up, the teachers put the remaining students into 4 groups for an activity. So there's 39 students that exist in some block, and then the other students get split into 4 equal pieces. Well, no, you don't split students into pieces. I mean, the group of students gets split up into 4 equal-sized groups is probably a better way of saying that. And I think that matches this tape diagram, because however many students get put into those groups is going to be x. Oops, I didn't mean to click that one down there. All right, the next one says Latifa buys a pack of 87 pencils. Okay, She gives 39 to her teachers and shares the remaining pencils between herself and 3 friends. So it's almost like the same thing, right? You start with a total of 87 things. 39 of them get taken away for whatever reason, and the rest get split into 4 equal groups. And it sounds like that's what's happening here. And so I'll click that one. The next one says Emiliano buys 4 packs of paper clips with 39 clips in each. This already doesn't sound right, right? 4 packs with 39 each. 4 times 39 is like 136, I think. 126? Something like that. No, 156. Got it. The total length of this thing is only 87. How can we have 156 or something? We're way too high. I'm not clicking that one. All right, and last, Shanice's family buys 4 tickets to a fair and spends $39 on dinner. They spend $87 total. I think this one works as well, right? Each X could represent 1 ticket to the fair, and then you tack on the $39 for the dinner, and the total is 87. All right, this one's an extra credit. It's super hard, if you ask me. This is really like an abstract way of looking at an 8th grade skill called systems of equations. This is what you would call a system of 4 equations, right? You have 4 tape diagrams here, and you have 4 variables. And there's only one set of solutions, one number for A, one number for B, one number for C, and one number for D, that makes the whole thing work properly. That's called a system of equations. And you don't even necessarily have to know this in 7th grade. If you know how to do this, or you want to think your way through logically, step by step, and think, okay, if this is this, then maybe that could be that, and figure it out, great, go for it. But it's an extra credit optional challenge. You don't have to do it.